Okay, so have you ever heard of quantum computers? You know, those things that are supposed to be like super powerful and can solve all sorts of problems that regular computers can't even touch. Well, they're usually these like massive machines that take up entire rooms. But what if I told you that scientists are working on shrinking them down, like way down, to the point where they could fit in your pocket? Yeah, you heard that right. Quantum computers in your pocket. It sounds crazy, right? But it's all thanks to this tiny little device called a photonic chip. It's basically like a miniature quantum playground where they can manipulate light and atoms with incredible precision. And get this, researchers at UC Santa Barbara have actually managed to trap and cool atoms on one of these photonic chips. It's a huge breakthrough that could revolutionize all sorts of fields, like sensing, timekeeping, and of course, computing. So how does it all work? Well, it all starts with a weird and wacky world of quantum mechanics. You see, down at the atomic level, things don't behave the way we're used to. Particles can be in multiple places at once, they could tunnel through walls, and they can even be linked together in a way that lets them communicate instantaneously, regardless of distance. It's like the rules of reality go out the window and are replaced with a whole new set of possibilities. And those possibilities, well, they have the potential to change the world as we know it. Now, working with these quantum phenomena used to mean dealing with bulky equipment, lasers, mirrors, and all sorts of complex setups that could fill an entire room. But these photonic chips are changing all that. They're basically like tiny optical circuits, etched with channels and structures that can guide and manipulate light with incredible precision. We're talking about controlling the movement of individual photons, the particles that make up light. And by using these photons, they can actually trap and manipulate atoms. It's pretty mind-blowing stuff. Now, one of the key things you need to do when you're working with atoms at the quantum level is to cool them down, like way down. We're talking about temperatures just a fraction of a degree above absolute zero. That's colder than the coldest place in the universe. And the reason they need to be so cold is that at those temperatures, the atom's quantum nature really starts to shine through. They become incredibly sensitive to their surroundings, and they start to exhibit some really strange and amazing properties. It's like they develop superpowers. These superpowers make them ideal for all sorts of cool applications. But traditionally, to get atoms this cold, you needed those massive lab setups I mentioned. But now, thanks to these photonic chips, they can do the same thing, but on a chip the size of your fingernail. It's incredible. They've essentially created a tiny quantum refrigerator on a chip. It's called a magneto-optical trap, or MOT for short. And it's like a tiny force field that holds those super chilled atoms in place so we can study them and put their quantum superpowers to work.
So how do they actually build these MOTs on a chip? Well, that's where things get really interesting.
Well, imagine these cities have these tiny channels running through them. And these channels, they act like fiber optic cables, guiding light beams around with like laser precision. And you know how fiber optics can send information over like really long distances? Well, it's kind of similar here. Researchers can use these channels to manipulate the light and atoms on the chip. But it's not just about like guiding the light, it's about like shaping it too. They can create these tiny structures on the chip, like mirrors and gratings, I think they're called. And these structures, they interact with the light in like very specific ways. It's kind of like building a tiny obstacle course for the light beams, splitting them, combining them, bouncing them around like a microscopic pinball machine. It's pretty wild. And one of the key parts of this whole setup is something called a grating emitter. It's like a tiny lighthouse on the chip, sending out a focused beam of light in a very specific direction. And by carefully positioning these grating emitters, they can create a region where like multiple light beams intersect. And that's where the magic happens. That's where they form that MOT, the magneto-optical trap, that tiny force field that traps and cools the atoms. And the really cool thing is that at UC Santa Barbara, researchers have actually made a photonic chip MOT that uses 3 of these grating emitters. And get this, they were able to trap and cool 1,000,000 atoms using this chip-based system. 1,000,000 atoms, that's a lot of atoms. And it's enough to start doing some like really groundbreaking experiments. But, creating these chip-based MOTs, it wasn't exactly a walk in the park. It was like incredibly challenging, like trying to build a watch with tweezers under a microscope. One of the biggest challenges was figuring out how to get the light from like an external laser into those tiny channels on the chip. It's like trying to thread a needle the size of the human hair. It requires like insane precision. And then once the light is inside the chip, it has to travel through those tiny channels without losing too much energy. Because any loss of light, it means less power for trapping and cooling those atoms. So the researchers had to get like really creative. They had to design and fabricate these channels with incredibly smooth surfaces, like minimizing any bumps or imperfections that could, scatter or absorb the light. It's like building a super smooth highway for light, ensuring a smooth and efficient journey. But wait, there's more. They also had to make sure that the light beams coming out of the grating emitters were like perfectly aligned and shaped. Remember, we were talking about trapping atoms that are like incredibly small, so the beams need to be like ridiculously precise.